Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vector and parametric equations for lines in R2. So let's start with part A. So if the equation of a line is R equals S parentheses 3 comma 4 and S can be any real number, name the coordinates of 3 points on this line. So we are given the equation of a line in vector form. The general equation of a line in vector form is now in this given equation there is no vector r0 and r0 represents a known point that lies on the line. So that means in the given line the vector r0 is the 0 vector or vector 0 comma 0. So we can rewrite the given equation as so there's a very important concept you need to understand and memorize. So one point that lies on this line is represented by the position vector r0. The point is 0 comma 0, the origin. So that's the point number 1. In order to find another point on this line, we should sub in the value of the parameter s as 1. So we get now multiplication of vector 3 comma 4 by 1 doesn't change the vector 3 comma 4. So we get now we can add these vectors by adding their x and y components. So the x components are 0 and 3 and 0 plus 3 is 3 and 0 plus 4 is 4. So that means another point that lies on this line is 3 comma 4. We can find the third point on this line by subbing in s as -1 in the equation. Now we can multiply the components 3 and 4 by -1 and now we can add the vectors. So 0 plus -3 is -3, 0 plus -4 is -4. So the third point that lies on this line is -3 comma -4. So these are the 3 points that lie on this line. Now we can analyze part B. Write a vector equation different from the one given in part A that also passes through the origin. So we can write a vector equation that's different from the given equation by changing the direction vector of the line. The direction vector of the given line is 3 comma 4. So for the vector equation in part B, we can use the direction vector 1, comma 1. So this direction vector is different from the direction vector of the given line. So the vector equation of the new line will be so we used the position vector 0, 0 because the line passes through the origin. In the final answer, we can ignore the 0 vector. So this can be the final answer for part B. Now we can analyze part C. Describe how the line with equation r equals 9, 12 plus t 3, 4, t can be any real number, relates to the line given in part A. So we have to compare this line in part C with the line given in part A. So we can see that both lines have the same direction vector 3, 4. So that means these lines are parallel to each other. But we should check if the lines are coincident. That means whether they represent the same line. So for that, we should check if the point that lies on the given line in part A lies on the line given in part C. So we know that point 0, 0 or the origin lies on the line given in part A. So we should check if this point lies on the line given in part C. So for that, we can write the equation in part C in parametric form. So that will be now we can sub in x as 0 and solve for t, and then sub in y as 0 and solve for t and check if we get the same value of t. So I get t equals -3. Now we can find the t value from the y equation. I got the same value of t from both equations. That means the point 0, 0 lies on the line given in part C. That means the line in part C is the same as the line in part A because they have the same direction vector, and the point 0, 0 that lies on the line in part A also lies on the line given in part C. So we can conclude our answer as the lines in part C and part A are the same. So this can be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.